Welcome you all to Unit 2 of Programming 2, that's arrays. We've gone through Unit 1 where we're looking at functions. We went through so many components and functions. What a function is, how we define a function, how we declare a function, and how we call a function. We also looked at two different types of parameters that actually receive values and those which receive a reference. So we went through reference parameters and value parameters, tried to identify the differences between the two, and we also looked at default parameters and overloaded parameters, overloaded functions. The last part was part of recursive function. That was after we covered the creation of headers, programmer defined header files. The last part was that of recursive functions. I hope you've gone through that part and you are able to create recursive functions. So let's begin. Unit 2, arrays. What are we covering in this unit? We are going to cover the definition of an array and how do we declare and initialize an array or assign values to an array, and displaying values of an array, and the concept of two-dimensional arrays. Arrays can be 2-dimension, 1-dimension, or even 3-dimension. So our discussion will stop at 2-dimensional arrays and many manipulations or processes that are done in an array. So here we are showing you one manipulation of that nature, that is searching a value in an array. But we have so many other things that we can do, manipulations we can carry on our array. We can search a value, we can search a highest value, we can search a smallest value, we can sort our array, and many others. Okay, so what is an array? From what we've done to this far, we've been using one variable to hold a value. Whenever we declared a variable, that variable was creating a space that should be used to hold a value. For example, if we had int num, it means we are creating a variable with a name num that should be used to store data of the type integer. So we've been doing that. So if we are to come up with a maybe program that should add 100 values or 100 integers using the order approach, it means we're supposed to declare probably 100 variables. Each variables would store one value and would add these values together. But now we are saying sometimes we may have data which is related. Usually maybe it's a data of the same type and it's related. We want to be handling that as a single entity. That calls for an array as the simplest form of a solution. So with arrays, we consider this to be a group. It works the same way the simple or one value variables work, but here we are storing a group under the same name. So we can, instead of having 100 names for 100 integers, we are going to have 100 integers but with the same name. Okay, so an array is a method of storing many values of the same data type under the same variable name. This is a data structure. We have other data structures, as you are going to see in your career of programming. So an array is one of those data structures in which data of the same type can be stored. So very important here, we are making an emphasis on the same data type. Same data type. It's a collection of data, yes, but the data is of the same type. So this is one characteristics of an array. We're going to see another one probably in the last bullet here. So, and it provides a way of retrieving each data item in any order. We are going to see what this means later. But here we say array values are stored in contiguous memory addresses in the computer. So we have a memory address, is our RAM. When we declare a variable, maybe we declare two variables, int a, comma b, we have two variables declared, a and b. These two variables may not necessarily be assigned or allocated the adjacent addresses. The first variable a may be on one address which is very far from that of adjacent, of the variable b. So they may not necessarily be close to each other, because these memory allocations are done randomly. So it can be allocated any free slot on the memory. So A and B, despite that they have been declared almost immediately one after another, will not occupy contiguous memory. So one characteristic or another characteristic of arrays is that when you have declared an array, all the variables, so to say, all the spaces allocated, if it's an array of 10 numbers, all the spaces to store 10 numbers will be next to each other. Let's see. Here we have a representation of an array. We are making an assumption that we have declared an array, and this is an array which is holding any numbers. We can have maybe 100 numbers, etc. But here we have just shown about 6 numbers. So we are taking this blue area as a RAM, which is continuing all the way here. It can continue to whatever. If we are to declare A and B, maybe A would have been allocated in the first slot here, and maybe B would have been allocated in the last slot here. We don't know. But with the arrays, if we are to declare array of n numbers, let's take for example of 6 numbers, then the spaces will be created that can be used to store 6 numbers next to each other. So from here we see we have n numbers that are declared as an array. So the important parts that we should know, or important things that we should know from this representation of our array, is that the numbers inside here are the actual values that we give to our variables. And we have the addresses here. We are just trying to show here that the addresses are next to each other, that these values have been allocated spaces next to each other contiguously. But for the discussion of our chapter, or for this chapter, we are not interested in the memory addresses. What is of importance are the elements, these values, and of course the indices, because we are going to be using indices to randomly retrieve values of our array. So the indices begin from 0. The first element of our array is given or is on position 0, and it goes all the way to the last one. So if we have an array of 10 numbers, it means the indices will start from 0 to 9. So if we have an array of n numbers, then the indices will start from 0 to n minus 1 as our last index. Okay, so let's see how we declare and use arrays. Okay, before we go there, these are just things that I've been discussing there. An array has got a name, and each element or the value of an array, we call it an element, and we have indices, which are actually the values here that are used to state the position of an element. And the indices are also called the subscript. So an index is a subscript, and an array has got a size, and we have also talked about the range of the indices, etc. In other languages, it's possible that you can have arrays starting from, for example, maybe negative, or starting from any other number. So, but in our case here using C++, we'll be using a default setting where the indices starts from 0. An array is declared as follows. The same way we've been doing with any variable. The only difference is at the end we specify a size in a square bracket. With a variable, it was just as simple as int grades. But now we are saying int grades 5. Why 5 at the end? This is a number that is indicating that we want a container, or we want a space for 5 numbers that should be maybe accessed or used, should be accessed or manipulated using the same name, grade. Okay. So here's another example. Double salaries, 10. So this one, it means we are going to have 10 salaries, or 10 double values, the numbers with the decimal points, 10 of them, and these will be allocated a space next to each other. So we are just creating a container. We haven't put the values yet. As we did before, we just declare a variable, and later we would assign values to those variables. Okay, so here we have another one. For the character data type, we want a variable, an array that should be able to store 20 characters. We are going to see or discuss more about character arrays, or arrays of data type character, in our next discussion, next unit, so to say. That will be on strings. Okay, so after I have declared, okay, another way of declaration, sometimes we can make a declaration and assign. As we saw before, we would declare a variable and assign immediately. We would have something like int a equals 20. So for arrays, we can also do the same. Int grades, then you can specify the values. So the grades here, we are saying 5 grades we want. So then you can specify the value. If it's, for example, maybe grades for quiz, maybe for BIT, first quiz, then BIT, I think is almost 35 students in BIT. So it will be something like int grades 35 equals, or maybe int quiz 1 as a name, then 35 equals, then I would list the scores for all the students. So we can handle all of that as one item, quiz 1, or BIT quiz 1, whatever name we can give. But this is how we can initialize immediately when we are making our declaration. When you are using this, you can omit, when you are initializing immediately, you can omit the size of an array. You can just have something like this, then equals, you specify the numbers. So the size of the array will be determined from the number of elements here. Okay, thank you. In the next video, we are going to look at how we can actually assign values. We make a declaration first and assign values, and how we can actually use these values. See you.